Alrighty, so go ahead and set up the left-hand side of your journal and title it Area of a Composite Figure. What we're going to be doing today is actually finding the area of composite figures. So what that means is we need to understand what a composite figure is and remember all of our different area formulas from last year. So this is the cookie cutter definition of a composite figure. So go ahead and copy this on the left-hand side of your journal. A composite figure is a shape or figure that can be broken up into more than one. So let's take a look at this house here. As you can tell, like the garage door here is a rectangle, and then the roof is a triangle. So now we got rectangles and triangles. We got another rectangle here, another triangle there, another rectangle here. So there's so many different shapes that actually make up this house, and that's what makes it composite, because we can't say this house is a rectangle or this house is a triangle, because it's not. It has a bunch of different shapes. I'm sure you remember in elementary school when you used to play with these little blocks, right? And you would, I know I remember when I was in elementary school, I would always use these and put together all these different cool little designs and patterns. And what you were doing then is actually making composite figures. So when you would put the little diamonds with the pentagons and trapezoids and make all these cool designs, you were creating composite figures, because these are all different shapes, but together you made one big one, okay? So in order for us to really understand composite figures, we need to remember some of our area formulas for these particular shapes. So the three main important area formulas that we need to know are for a rectangle, a triangle, and a circle, okay? And I'm just writing the names, but you all know what these shapes are, okay? So the area of a rectangle is really easy. It is just base times height. And you did this last year in 6th grade, but it's pretty easy. If I tell you that this height is 8 and the base is 10, all we would do is plug in 10 times 8 and get 80. So that's how you find the area of a rectangle. The area of a triangle is very similar, right? So we're going to do base times height, but then we're going to divide it by 2. And the reason we do that is because when you look at a triangle, it's kind of like if we were to have two triangles together, it would make a rectangle, right? So what we do is we take the area of a rectangle and then divide it by 2, okay? And lastly, a circle, which we did it last week, is pi times r times r. Or another way to write it is pi times r squared, meaning that we see r 2 times, okay? So we're not going to be using this area formula too much with composite figures, but it's still important for you to know and remember how to find the area of a circle. All right, so let's go ahead and figure out this composite figure. Now, there are a couple of shapes that I see in this particular composite figure. The first one that I see is this rectangle right here. Okay, this is a rectangle. So I know I'm going to need to find the area of a rectangle, and that formula is base times height. So I know I'm going to have to use that one time because I see one rectangle. I also see a triangle right here, right? And the formula of a triangle, where's my eraser? The formula of a triangle is area equals base times height divided by 2, okay? So let's go ahead and find the area of our rectangle, all right? Now, the base of the rectangle right here is 14, and it tells me right here that the base is 14. So I'm going to put 14, and the height going up is 12. So I'm going to make my height 12, okay? Then using my calculator, I'm going to do 14 times 12. My area, therefore, is 168, okay? My area is 168. Now we're going to do the same thing with the triangle. And one thing that's important to notice is that the area or the base and the height of the triangle is very different. So the base for the triangle is actually 8. It's not 14 anymore. 14 is of the rectangle. The base is 8, and the height going up is 12. So it still shares that height with the rectangle. But don't forget, we have to divide that whole thing by 2, right? So I'm going to do 8 times 12, get 96, divided by 2 will give me 48, okay? So the area of my rectangle is 168, and the area of my triangle is 48. Are we done here? The answer is no. Because now what we need to do is, because we have one big shape, we have to add these two areas together. So I'm going to add 168 plus 48, okay? And I'm going to get 216, okay? So my area of this shape is 216 centimeters, okay? Go ahead and take a moment to copy this down in your journal, and then we can get started on the next problem. Okay, this one is super tricky. So if I were you, I would make sure to pay extra attention to how I solve this. So the first thing is I try to call out the shape. So I definitely see here a rectangle. And then I definitely see a triangle. Now, the one weird thing about my triangle is I don't have any dimensions for it, meaning I don't have the height or the base. So what that means is I'm going to have to try to figure that out. And that's where the tricky part comes in. So make sure you're paying close attention. I can easily find the base of the rectangle. I have 12 centimeters is the height. And the base is 15. Now, why is the base not 22? Notice how this 22 goes beyond the rectangle. If I were to draw a line for the rectangle, it would end right here. And this 22 is too big. It goes longer than that. It goes into the triangle. And I don't need this whole number. So I'm going to use the 15 as my base. Okay? Then I'm going to multiply 12 times 15, and my area is going to be 180, okay? Now let's figure out the triangle, right? Now, if the height over here is 12 of the rectangle, then the height on the other side of the rectangle is also going to be 12. So that means that is the height of the triangle is going to be 12. If you look at it right here, it's going to be 12 here and 12 right over here. Now, we can follow that same rule with the base, right? If the base is 15 over here, that means that the base is going to be 15 down here. So the question is, if this part is 15, how much is this part, okay? We need to get a total of 22. So 15 plus 7 will give us 22. So that means that the triangle right here, this little part of the triangle is 7 centimeters because this one is 15 and we need a total of 22. So now I can figure it out. I can do 7 times 12, and then don't forget I have to divide by 2. So 7 times 12 divided by 2 gives me 42. Now, am I done? No, because remember, we have to add the area of the rectangle to the area of the triangle, and that'll get us 222 centimeters. So the area of this composite figure is 222. If you're feeling confused about this problem, this is the time where you raise your hand and ask Mr. Cador or Miss Milton on how you do this. All right, last problem. So here, this one's a little bit easier because I see one rectangle here, and then I see another rectangle here. Now, some people may say, Miss Davis, I didn't see it that way. The way I saw it was, and let me erase this so that you can see it a different way. Some people may see this whole thing as one big triangle, and then this one as another little one. It doesn't matter how you see the shapes, right? We can all see things differently. However, at the end of the day, you're going to get the same answer. And that's the thing about math, is there's so many different ways to solve a problem, but you're always going to get the same answer, okay? So I'm going to do it this way then. I know that this whole thing here is 15. So I'm going to put the area equals base times height. And I'm going to do that 2 times because I got 2 triangles, or excuse me, 2 rectangles. So I know this base is 15. And the height of this one is 2. Okay, this one's a little bit tiny. The height of this particular rectangle is 2. So 15 times 2 will give me 30. Okay, perfect. Now I gotta do the next one. So there's this triangle right here. Now the base of this one's easy because it tells you right there the base of that one is 7. So my base is 7. The question is, how much is this height? Okay, that is the tricky part. Now over here, it tells me that it is 3 centimeters. This whole thing is 3 centimeters. So if this piece is 2, how much does this piece then have to be? This needs to be 1, okay? Because if this total is 3 and already we got 2, we're missing 1 centimeter. Now, I know what you're thinking. That does not look like 1 centimeter. That looks much bigger. The picture isn't true to size, but we're going to go with the idea that if this is 2, then this has to be 1 to make 3, okay? So we're going to do 7 times 1. And that was easy. 7 times 1 is 7, okay? Now, last step is we got to take the areas, 30 and 7, and add them together, and we will get 37. So this has a composite area of 37. Alright, so here's your classwork. You got 4 different problems that I want you to do on a separate sheet of paper, and I want you to turn these problems in. If you have any questions or you need any help, feel free to raise your hand and ask one of your iPrep facilitators to help you.